We have been talking several times during these days about safety and security, but we are obsessed looking at it just at the source code language level. And I think Luis has a slightly different perspective that needs to be considered too. So, Luis, thank you very much for coming to the conference, and the floor is yours.
Nice. Thank you so much. My name is Luis Caro, and I'm part of the Conan team as well. So this is going to be a tough act to follow after your boss gives a talk, but I'll do my best today. So I guess we've all heard about this in the past year. There's been not one document, but not one particular government, but like several documents as well, sort of outlining that there needs to be a focus on security. There's alarming concerns about memory safety to the point where it's being advised that new products use a memory safe language to be developed in. Obviously, there are reports, there are words, but this is what we get in the news. Stop using C++. Stop using C++ by 2026, which is, I think, next year. So we have less than 9 months. And this one talks about critical software. Okay, so different takes. And then obviously these things were in the news in several places. And then I go on like my socials, whether it's LinkedIn or whether it's like Twitter, C++. And this is the sentiment that I perceived. I don't know if people here felt the same, but this is how I interpret it. Obviously, the reality is not as stark. If you actually go through the documents and the recommendations, it goes beyond that, right? One of the big things I'll just cover briefly later is memory safety roadmaps, right? So yes, it is true that there is a very, very specific recommendation of if you're going to develop new products, use memory safe languages. There is a list of which languages are considered memory safe. I'm surprised about Python because the Python interpreter is written in C, but there we are. But for everything else, it advises to have a plan, right? A memory safety roadmap. And it's also acknowledged that rewriting everything in memory safe languages is very costly and impractical. And that even for products that you are going to be using these languages, they have to interface. And I think Python is a good example with software that is written in different languages like C++ and C. And it also acknowledges, although there isn't anything yet there, about safer language subsets, right? And here we have a lot of like efforts that I'm not going to cover in this talk, but there are good papers about this and things coming in C++ 26 and beyond about, increased like safety hardening in C++ and so on, or better practices as well. But what I'm going to focus today is a specific part of these recommendations, that memory safety roadmaps, which is the last 3 points, right? Like have an external dependency plan, transparency plan, and a CVE support program plan, which is basically, in different ways, care about security and have a plan to react. So I'm going to take another example of something that happened in the last year, which is the XZ Utils backdoor. I think most of us have heard about this here, and some of us may have been received a phone call while we were at the barber about this, so just to react to this. So this is what happened, right? And interestingly, this was not a memory safety issue, right? And it was also not C++, but it is very common, and I'm going to show this later, that this could be used, this could affect your C++ programs, right? So I'll show you later. But first, I'm going to cover a few of the acronyms here, like CVE, the common vulnerabilities and exposures, right? This is a way to use the same identifier for the particular vulnerability, right, across all like bug reporting systems, across like Linux distributions and so on and so forth. The idea here, the CVE is just the identifier that describes in a very which component is affected and what type of vulnerability we're talking about. But we have more things. We have the National Vulnerability Database, which for a CVE ID, it's going to provide more detailed information. So specifically, we have a score as an impact. So we have critical would be 10 and lower risk would be closer to 1. It also explains specific attack vectors and what conditions need to happen for the vulnerability to actually happen, and remediation. In a lot of cases, remediation could be disable this setting or move to a version that's already patched and things like that. We also have another acronym here like CWE, Common Weakness Enumeration, which is a family or type of vulnerability, right? So for C and C++, we may see something like this: buffer overread, double free, use after free. These are the typical things that we will find when we say memory safety. These are the things that could happen and potentially make our software, the software we write in C++ vulnerable. But obviously, there's a lot more acronyms that I don't have time to cover today. But here's, I mentioned a few of them if you want and have time to look into that. But back into the XZ Utils vulnerability here, as I mentioned before, it's not a C++ library. So C++ 26 and beyond features are definitely not going to help here. It's not a memory safety bug. So it was actually a supply chain attack where a maintainer with bad intentions embedded malicious code into the build system of the library. And as I mentioned earlier, you may not be using this library directly at all. You may not even be aware that your software is affected, right? Which is part of the problem and what I want to highlight today. So imagine that we have our awesome product, which is written in C++. I have here on the left a C++ application. It's very simple. It just loads a video file and it loads a machine learning model. The code is clipped. There will be more things. And it just tries to do post estimation, pretty much like the demo we have outside in our booth, right? And we have a CMake list that we call find package. We have two dependencies. We use TensorFlow Lite for the machine learning part, and we use OpenCV for the video processing and to overlay the post into the video and to display the windows. So it's a very simple program. I think you'd be familiar with this. And also we have a Conan file to specify the two dependencies that we have here. And what I have highlighted in yellow is how we do with the dependencies in each of these files, right? In the CMake list, we use find package, so we have the package name, and we also use the target names down there. In the Conan file, we have the very similar names and the version as well, specific versions that we depend on. And in the C++ file, we're obviously going to have the header files and classes and functions. Now, we have dependencies, right? That's probably the takeaway from this. From the annual survey, developer survey, right? How do you manage your C++ first and third-party libraries? To this day, the library source code is part of my build. It's still like the top response, which has me a little shocked, to be honest. So when it comes to responding to a vulnerability, I personally think that it is more difficult to react to this if the library source code is part of your build or if you're compiling things separately using instructions. So imagine that you are compiling the library separately using instructions and you have a team of 30 developers. Are the 30 developers supposed to do that on their machines? And if you have to react to a vulnerability, first of all, are you even aware that you have this in your build? And what I've seen over time is like, raise your hand if you have the source code of zlib somewhere in your project rather than using it externally. Okay, I see quite a few hands actually, right? Imagine that this was checked into your code base 10 years ago. Have you been keeping up with the latest versions? Have you modified things, the source code? I've seen that in the past where we checked in a third-party library in our source code and it's been modified. So if a vulnerability is reported, am I even going to know? And does it even apply? Because we've as a team, we've made changes over the years. So I personally think this is very, very risky, to be honest. And also downloaded pre-built libraries from the internet, depending on some circumstances. So this echoes my sentiments when it comes to doing that. So my first point of advice, for not only for the practicalities of how things can be easier as well, is use a package manager, right? Just using a package manager is actually helpful in terms of managing the dependencies, tracing the changes that you make to dependencies in a way that's isolated from your code base. And also it allows you to react faster because one of the most common ways of reacting to a vulnerability reported is just switch to a newer version that's already patched. So now I'm going to move to discuss security practices, especially touching on the points from the memory safe roadmaps. The first one would be know your dependencies, right? I show you a C++ project that uses 2 dependencies, right? But as I mentioned, it actually uses XZ Utils. And first, I'm going to mention, talked about software bills of materials, which I've heard in the early talk today. And it's just a very simple concept. It's just a list of the software components that my product uses, right? So if I have my awesome product, I would go beyond listing TensorFlow and OpenCV, right? If those 2 libraries have their own dependencies, they would also have to be listed in software bill of materials, right? So what we would have is a file that describes, that lists these components, maybe with their names, maybe with their versions, maybe with different metadata, like the website, specific patches that may or may not have been applied. So it's very open in that sense. To me, the interesting part is who uses an SBOM and for what, right? And I think everybody involved in software, whether you write it, you maintain it, you sell it, or you use it as a consumer, right? The SBOMs are going to become increasingly important. So raise your hand if you're already producing SBOMs or you are required to do so when delivering software. Okay, quite a few hands as well. Not as many as I leave in your code base, but it's good to see this moving in the right direction. We do have 2 common file formats right now that seem to be converging to either of these 2, right? Both are machine readable and both contain like very, very similar information. So I'm just going to do a demo now of how you can use Conan to generate CycloneDX software bill of materials for the application that I just showed earlier. So this is the file that I showed you earlier, this Conan file.py that I list those two dependencies. And the feature that we have is we can tweak the recipe a little bit to say, hey, when I call Conan install, please generate the SBOM in the CycloneDX 1.4 format and save it in a JSON file. So that is the demo that I'm going to do now. If things work well. Right, so let me increase that size here a little bit. Perfect. And I'm just going to call Conan install here, but first let's see, check that the code is the same. And what this is doing, Conan is processing the dependency graph. And then let me open this file. And it has generated the SBOM, right? So what we're going to find here is a very, very long list of components, because as I mentioned, this is now listing the entire dependency graph of both OpenCV and TensorFlow Lite. And here, what we're going to find somewhere, if I've done this right, is actually, we can confirm that XZ Utils in the bad version is in this project. In addition to listing all the components, it also lists which components depend on which as well, so it can actually help you understand where in your code base this is actually being used, or if it's being used at all, because it's not uncommon to have a C++ project that uses dependencies. There are going to be dependencies that are maybe optional and are not used by any of your code paths at all. My advice would be disable them, right? But not everybody or every developer cares about this, and everybody's in a rush sometimes to deliver, and so that would be a point of action. So going back here, if we were to process that file and trying to understand the dependencies, we would actually be able to see this, right? We have our product. Our product depends on OpenCV, which depends on both libtiff and FFmpeg, and both have an optional dependency on XZ Utils, right? A potential remediation here would be to just like rebuild them without that, which can actually be done with Conan as well. So obviously Conan already has its own tools to show the dependency graph, but here what we added to the client is the ability to produce the file in a standard format. Now the next thing that I'm going to be talking about in terms of features that we've added is know if the dependencies that you're using have vulnerabilities, right? So SBOM is first step, is like knowing what dependencies my application have is obviously the first step to actually query in a database. Oh, hey, is XZ Utils version 5.6.1 affected by anything? So let's check. So for that, we have introduced just this week the Conan audit subcommand, right? This is going out in the Conan, is it 2.14? Version Conan 2.14, which is out now, and what this does is it works with the Conan dependency graph, and it also leverages the information that we have from our colleagues in JFrog Advanced Security to go through your every dependency that is in the graph and check, hey, are there vulnerabilities listed for that dependency and that particular version? So I'm going to be doing a demo of this as well, hoping that the internet doesn't betray me. So what I would do is in the same directory that I would just call Conan install, I'm going to call Conan audit scan and just tell please do this directory. And this is going to connect with our servers, and it's going to check the vulnerability info for every dependency that's in the graph, which, by the way, is a lot. And we are going to see quite a few interesting things here, which should be coming soon now. There are actually a few dependencies that have vulnerabilities listed, right? This is from last year, so there's some things are deliberately kept on older versions. And what we have is a summary here that these libraries have these vulnerabilities as well. So obviously, this is the human-friendly command line output, but we also have the ability to do an HTML output as well. So here we can get the list of, and you'll see this program has a lot of dependencies, but I only have 2 direct dependencies. And here we can see XZ Utils 5.6.1, and it tells you the CVE that's affecting it, and some links to the references as well. And for this, you can actually, act. So it's not only know your dependencies, and that's the purpose of the SBOM as well, is to have a process that you may want to run maybe during a nightly build, for instance, or while you're developing as well, to say, hey, we need to do something about this, right? And when combined with SBOMs as well, what is interesting to me, even as a consumer, is if I was a consumer have an operating system or some piece of software, or even any app on my phone, everything came with an SBOM, you'll be able to react faster to these things, so you would know. So I think that's a bit of transparency as well from that the roadmaps do mention. So there we go. Sorry about this. Those were my fallback. So in order to be able to use Conan Audit here, you would have to go to this website, first register, you obtain a token, you activate a token in the Conan client, and you're ready to go. So you will be able to just call Conan Audit as I did earlier. And so I'm going to leave this for one more second in case you want to take a point of the link. So this is a very simple process as well. The initial setup on the Conan client would be something like this, where you just tell, authenticate the Conan Center vulnerability provider, your token, and that's it. Once you're authenticated, you can actually use it. This is, as I mentioned, this is already available as of this week. You can register there, and if you have more information, if you want more information, you can check our blog post as well, and provide feedback either in our GitHub issue tracker and the Conan research at JFrog.com. When it comes to this. So these are not the only security oriented features that we have in Conan. I've shown you Conan Audit. We have CycloneDX SBOM generation as well. And one of the things that I mentioned is you saw that I modified the recipe to generate it during Conan install. But actually, the integration is delivered so that you can actually use it however way suits you best. So some users have actually requested, hey, can I generate it after the package is already generated, put it in the metadata folder, so when I upload that to Artifactory, maybe I can actually go in Artifactory and see the SBOM attached to every package, right? You can do that in the metadata folder. You can even add it as part of the package as well, so that if you have tooling or something else or any auditability audit trail that you need to provide either internally to your customers, this can be part of every Conan package as well. We also have a package signing feature in case you need to make sure that anybody downloading packages from your source know that it comes from a trusted source as well. We have, if you're using Artifactory as your Conan server, there's extra integration. So you can create rules that would prevent any of your developers from downloading a dependency for which a critical SVE has been found. So for instance, I could configure my Artifactory to say, hey, any vulnerability with a score higher than 7.5, please prevent my users from being able to download it, right? So maybe you have an nightly build where you're either integrating Conan Audit or you're using something like this, and you would know the next morning. And that will give you a tool and information to react more quickly and to issue an update, perhaps. So like I said, everything is there to help you or to help your software be more secure quicker. Now, I'm not going to cover how to react to vulnerabilities as well. This is only the first step, which is having information, right? The project that I showed you earlier, the solution was not necessarily roll back to an earlier version of XZ Utils that was not affected by the vulnerability, is to actually go through the dependency graph and disable anything that was not used by our product, right? So there are different ways of reacting to vulnerabilities as well. So we want to hear from you what you need from us to help you do that faster. So as a conclusion here, and I think it's pretty obvious from my earlier slides, use Package Manager. This actually does help you more than you realize in more ways than one. But specifically, use Package Manager that does put a focus on security as well. Thank you so much.
Thank you very much. I have to say I'm impressed. Really good job. So, questions? I should stay here every time.
So my question is about build systems.
Yeah.
So for example, you typically download CMake or GCC from the web or from the package manager of the operating system, whatever.
Yeah.
And that is not going to be covered by Conan. So
let me show you. Wait. So here, let me check for message. Is it not there? It was there.
It was there. Yeah, it
Yeah,
was in the command line. At least.
See, no. So we do check basically if you use Conan to actually model those dependencies, right? So in Conan you can use a tool requires to for CMake or Meson, something like that. Then it will be considered for both, or it could be considered for both. So the audit for sure would check the vulnerabilities of those as well. So the compiler, you would have to model the compiler as a Conan recipe. We do have a lot of users that do this. That would be an option, but then again, we would need to make sure that we actually track vulnerabilities of those in the database. I'm not entirely, I can't remember an instance where I saw an actual version of a compiler was producing vulnerable code, rather that was not the fault of the code itself. But absolutely, that's something that's sort of taken into account. Like if it's in the Conan graph, we can do something about it.
So your recommendation will be stop downloading CMake from the web, for example, and use Conan to fetch CMake?
If what you want is to make sure that it ends up in an SBOM or is checked against vulnerabilities, then that would be yes.
Okay, thanks.
Okay, more questions?
Hello. So regarding this audit, I have a concern. We are, for example, using the Chromium embedded framework that is not in Conan.
Yeah.
So all the dependencies of the theft provide huge vulnerabilities. And as this is not tracked by Conan, is there any way to, for ourselves, maybe do something so the audit reports them? Now,
possible. So at the moment, we require for in order to get a match in our database, right? The name of the package that you use needs to match something that's already published in Conan Center. If it's something public, do reach out to us by email. So if it's an SDK that's publicly available, and we'll see if there's a way to integrate that in the database as well, even if it's not published in Conan Center. If it's an SDK that actually contains a lot of dependencies as well, I think it may be worth reaching to the providers of the SDK so that they themselves can use an SBOM, right? I think interacting in this way with these providers is actually going to help bring the versions of vulnerabilities to surface as well. But like I said, you also need to, even if vulnerabilities are reported on all the versions of the library in an SDK, you need to actually find out whether you're actually using it or not, right? So, because it can be unnecessary noise sometimes. Everything has dependencies, but what matters is what your code does on the code that you deliver to your customers.
Okay, any other question? Oh,
Thank you. And my question is, how specific is this search for vulnerabilities? I mean, for example, if it checks the architecture, maybe the option flags used for the compilation of the
Correct.
package?
It's, at the moment, it's just the name and the version.
okay. Or they want coffee.
Thank you so much.
So thank you very much.